In this lesson, lesson 19, we are going to be studying antiderivatives and the indefinite integral. In this video, we're going to talk about our introduction here and do the warm-up. So over the last 3 months, we've been doing differential calculus, right? We've been looking at how do we get the slope of the tangent line at any point on the curve. We've been looking at how to find the instantaneous rate of change. We've rigorously defined that derivative. Remember, we're looking at it as rise over run as run goes to 0, right? We've calculated the derivative from the definition. We've learned a myriad of differentiation techniques and then used those techniques to explore applications, some of which have been rates of change, related rates, and optimization. So now what we're going to do is we're going to lay the foundation for integral calculus. We're going to investigate the antiderivative, which has another name called the indefinite integral. These guys are synonyms. Oh, yep, there it is. Antiderivative, also called the indefinite integral. In the next lesson, we're going to investigate the area question, and there's a surprising relationship between the tangent question and the area question, and you might be able to guess at it given that we're starting to talk about antiderivatives. In this lesson, we have 2 learning objectives. We're going to find general antiderivatives and then learn the indefinite integral notation for asking that same question, go find the general antiderivative. All right, in this warm-up, I want you to I'm going to read the first one with you, but then I want you to pause it and try to think in reverse. Now, I know we're doing a lot of stuff online right now because of COVID-19, but in your Calculus 2, one of the first things that you're going to be working on is thinking about derivatives backwards, right? So you want to have certain derivative rules memorized so that you can kind of start to think backwards. It's like if I try to do division without having my times tables memorized, this can be pretty hard. Okay? So in the first question, the derivative of what function is cosine x? So I want you to come up with a function. Maybe you can come up with more than one. Whose derivative is cosine. And then go ahead and check your answer by differentiating. Then you're going to do the same thing for 2 different functions. The derivative of what function is 4x cubed, and the derivative of what function is x cubed. All right, so I'm jumping back in. Hopefully you've had a moment to think about these. The derivative of what function is cosine x? Perhaps you came up with sine x. I'm going to name this function something other than f, right? F is cosine. But because there's a relationship between these two, I'm just going to use a capital letter F. Right? So the derivative of what function is cosine? We're saying the derivative of sine is cosine. If we check by differentiating, we get f prime, big F prime. The derivative of sine is cosine x, check. The derivative of what function is x to the 4th? Again, pause and take a moment with this. All right. Maybe you came up with the derivative of x to the 4th is 4x cubed. Checking our understanding that we're correct using differentiation. The derivative of x to the 4th using power rule is 4x to the 4 minus 1 power, 4x cubed. Beautiful. The derivative of x to the 4th is 4x cubed. Lastly, the derivative of what function is x cubed? All right, so I hope you paused it. This one takes perhaps a little bit more creativity than example 2. Perhaps you came up with something like this. The derivative of 1/4 x to the 4th. If I take the derivative of that function, do I in fact get x cubed? We have a constant, 1/4 multiple times x to the 4th, and the derivative of x to the 4th is 4x cubed. We've got 1x cubed, we've got x cubed. Beautiful. You could also write this is not a different function, but instead of multiplying by 1/4, if you'd prefer to write that as just division by 4, that's perfectly fine as well. Okay? In the next video, we are going to think about whether or not these functions that we found are unique. Is there more than one function whose derivative, when I take its derivative, I get cosine? All right?